Humans make groups. A group is one enclosure relates to a particular function, that is, functional group. Each functional group is standardized and it is independent of yard layout. We cannot add any relay into the group even though space is available to accommodate. Intra-relay wiring within the relay group is factory wired, that is, pre-wired and tested. Reduces the site wiring about 40% of total wiring, as these functional groups are pre-wired at the factory itself. In the circuit diagrams, this pre-wiring is shown with thick lines. One is not allowed to interfere with the group. K50 relays are available only in group units of different sizes. Depending upon the unit size, these groups are broadly classified as mini groups, minor groups, major groups. The capacities of various groups are: mini group class has K50 relay capacity of 2 relay space. Minor group class has K50 relay capacity of 15 relay space. Major group class has K50 relay capacity of 30 relay space. Advantages of relay groups. Modular construction of group unit facilitates uniform gear control independent of yard layouts. This enables easy additions and alterations to yard. Improves safety in their operations as the group wiring is done in factory and tested under ideal conditions. The wiring is well protected in its enclosed casing. The external wiring needed for interconnection of inclusion of other controls is greatly minimized, resulting in the saving of installation and commissioning time. Indications on relay groups facilitate quicker fault finding as they appear according to the relay operation sequence in progress. It helps for easy maintenance. No interference with individual relays. If any functional group is suspected defective, then the entire group is required to be replaced. It minimizes the failure time and also enhances the safety level. Are mini group with 2 number K50 neutral relays, 1 AC immunized and 1 non-AC immunized K50 neutral relays, or 2 AC immunized K50 neutral relays. 2 numbers K50 interlocked relays, lamp proving relays 3F3B for on and off aspect and 5F1B for route indicator lamps. Relay coils and contacts are numbered as follows. In top relay, the terminal number 01 and 02 spare, the terminal number 11 and 12 used for top relay for contact numbers 02, the terminal number 21 and 22 used for top relay contact number 03, the terminal number 31 and 32 used for top relay contact number 04, the terminal number 41 and 42 used for top relay contact number 05, the terminal number 51 and 52 used for top relay contact number 15, the terminal number 61 and 62 used for top relay contact number 14, the terminal number 71 and 72 used for top relay contact number 13, the terminal number 81 and 82 used for top relay contact number 12, the terminal number 91 and 92 used for top relay coils. In bottom relay, the terminal number 0304 spare, the terminal number 13 and 14 used for bottom relay, contact number 02, the terminal number 23 and 24 used for bottom relay, contact number 03, the terminal number 33 and 34 used for bottom relay, contact number 04, the terminal number 43 and 44 used for bottom relay, contact number 05, the terminal number 53 and 54 used for bottom relay, contact number 15, the terminal number 63 and 64 used for bottom relay, contact number 14, the terminal number 73 and 74 used for bottom relay, contact number 13, the terminal number 83 and 84 used for bottom relay, contact number 12, the terminal number 93 and 94 used for bottom relay coils. Code pins are provided in 8 positions. Code pin prevents the plugging of wrong configuration and type relays. Code pins position for various relays are given. For neutral relay, the code pins for 6F2B configuration, these are at 1st and 5th position. For 5F3B configuration, are at 1st and 6th position. For 4F4B configuration, code pins are at 1st and 7th position. For interlocked relay, the code pins for 4F4B configuration are at 3rd and 7th position. For 5F3B configuration are at 3rd and 6th position, and for 6F2B configuration, these are at 3rd and 5th position. For AC immunized relay, the code pins for one AC immunized and one non-AC immunized are at 2nd and 5th position. For group of 2 AC immunized configuration are at 2nd and 6th position. For ECRs, the code pins for on ECR are at 4th and 7th position. For off ECR configuration are at 4th and 5th position. And for UECR configuration, these are at 4th and 6th position. Guide pins will not allow plugging of relay in inverted position and will enable plugging of the relay in proper alignment. Mini group with neutral relay, non-AC immunized. It consists of 2 numbers of K50 relays arranged one on top of another on bottom positions. Top relay position number is 1 and bottom relay position number is 2. Each neutral relay is capable of working independently. This relay group has contact configuration of 4F4B, 5F3B, and 6F2B. In this group, top and bottom relays has same contact configuration. Mini group with AC immunized K50 neutral relays. It has contact configuration of 5F3B only. AC immunity level is 450 volt AC. It is available in 2 types. Top relay is AC immunized and bottom relay is non-AC immunized. Both top and bottom relays are AC immunized. AC immunized relay is provided with copper slug for AC immunization and brass strip as a counterweight for reducing release time. Mini group with interlocked relays. 2 neutral K50 relays are latched mechanically to form an interlocked relay. It works as a memory device to detect the last operation. Top coil is called reverse coil and bottom coil is called as normal coil. Bottom relay is normally up and top relay is normally down. Pickup of one relay delatches, that is, drops the other relay. In this process, both the relay front contacts are available for a few milliseconds, that is in interlocked relays. Front contacts of the one relay breaks only after picking up of the other relay. To cut off feed to the reverse, that is top relay coil, after its armature is latched bottom relay, front contact is connected in series with the reverse, that is top relay coil, in its external energization circuit. These front contacts are called as Economizer contacts. since these contacts cut off the power supply to the latched relay coils after their picking up. When one relay is picked up, there is possibility of picking of other relay, but both coils can never be in dropped condition. Normally, front contact of top relay is equivalent to a back contact of bottom relay and vice versa, but in a few circuits, front and back contact variation varies. All interlocked relays are normalized after completion of movement, but in point group circuit, WLR relay remains in last operated position. Interlocked relay groups are available with 4F, 4B, 5F, 3B and 6F, 2B contact configurations. For neutral relays, front contact and back contacts are used as per requirement. But for interlocked relays, in one circuit up contact is used and then in next circuit its conflicting relay down contact is used. It is used to achieve an interlocking between conflicting functions. Originally, point and root group interlocked relays are used, but not in signal group. On demand it was provided at outside signal group. Mini group with ECRs. It comprises of a current transformer, bridge rectifier and a neutral relay of K50. Relay is provided on top position and power conversion unit provided on bottom position. ECRs are supplied separately for on aspect, off aspect and root indicator. On ECR, it is used for proving the on aspect of the signal. When both filaments of the signal lamp are lit, it picks up. When the main filament of signal lamp is fused, the relay drops. Off ECR, it is used for proving the off aspect of the signal. It picks up whenever off-aspect lamp is litting and drops when off-aspect lamp is fused or not litting. UECR. It is used for proving the root indicator of the signal. When at least 3 lamps are lit on the root indicator, the relay gets energized. If more than 2 lamps are fused in the root indicator, it drops. Types of minor groups. Main signal group, 3-aspect signal group, 2-aspect signal group, 4-aspect signal group used in automatic signaling section, shunt signal group used for 2 shunt signals, universal root group, point group for panel interlocking, point switching group which works as interface. Major group. Relays provided are 23 plus 1. 5 rows in the major group and 6 relay space in 1 row is equal to total space 30 relays. Z1WR1 point group controlling initiating relay. Normally de-energized relay. This is the first relay to pick up in a point major group for individual point operation. It has 2 coils. Z1NWR point normal control initiating relay. This is a double coil relay. This relay switched on normal point controlling relay NWLR. Once energized, it drops only when the point buttons are released and NWLR is energized. Z1RWR point reverse control initiating relay. This is a double coil relay. This relay switched on reverse point controlling relay RWLR. Once energized, it drops only when the point buttons are released and reverse point controlling relay RWLR is energized. Z1WR point group initiating relay. Normally de-energized relay. This is the first relay to pick up in a point major group for automatic point operation under root setting conditions. It has 2 coils but only 1 coil is used. This relay does not respond for individual point operation. WLR point locking relay. This is a double coil relay. It checks that the point group is initiated due to root setting only and not due to accidental lifting of URS or OVZ to URR. It checks the track locking condition, it switches on the point chain group and helps in sequential operation of points. WKR1, point detection relay number 1, to prove correspondence continuously. This relay detects the correct setting and locking of point in either position. These relay energize only when the point is correctly set, locked, and is in correspondence with point group and the points group is in detection mode. This relay continuously monitors healthiness of the points at site. WRR by WNR, point operation by detection circuit switching relay. This is an interlocked relay. When WNR, this is latched point detection circuit, is closed, and WRR, this is latched point operation circuit, is closed. RWLR1 by NWLR1, reverse binormal point operation control relay 1. This is an interlocked relay used for controlling point operation circuit. NWLR closes point normal operation circuit and RWLR closes point reverse operation circuit. These relays do not have heavy-duty contacts. RWLR2 by NWLR2, reverse binormal point operation control relay 2. This is an interlocked relay used for controlling point operation circuit. This is the repeater of RWLR1 by NWLR1. RWLR3 by NWLR3, reverse binormal point operation control relay 3. This is an interlocked relay used for controlling point operation circuit. This is the repeater of RWLR2 by NWLR2. WR by NLR, point group locking relay by point group lock normalizing relay. It is an interlocked relay. When a point falls in the route by overlap by isolation, WRLR picks up and locks the point group electrically. WNLR, when a latch indicates that the point is electronically free. WKR2, point detection relay number 2, to prove the out of correspondence and cross protection arrangement. It picks up whenever Z1RWR or Z1NWR is picked up during the points group initiation sequence and switches on point time element relay. Once WKR2 picks up, it drops only after the energization of WKR3 at the end of point operation. It energizes when the point at site and the point group is out of correspondence. It also energizes when the point detection circuit draws more than 120 mA current due to false feed or cable fault. Once WKR2 is picked up, results WKR1 drops. WR point contactor relay. This is a contactor relay having heavy-duty front contacts with current rating of 10 amperes. It is used for the point operation circuits. Points motor feed is switched on through these relay front contacts. WJR, point time element relay. This is a neutral relay. It is made slow to release for a time period of not less than 10 seconds. This relay controls the point contactor relay for a period of not less than 10 seconds to prevent the overloading of point machine in case of obstruction in point. This relay drops as soon as the WKR3 picked up at the end of point operation. It operates during sequence of relay operation in point group when the point operation from reverse to normal is initiated to disconnect the point detection supply of WKR1. Z2WR1, points zone panel indication controlling relay 1. This relay picks up when the point is operated during route setting to give an indication on point zone tracks in the route or overlap set for more important move. Z2WR2, points zone panel indication controlling relay 2. This relay picks up when the point is operated during route setting to give an indications on point zone track in the overlap set for less important move. TP1R, point zone track circuit repeater relay. TP1P2R, point zone track circuit repeater relay. WKR3, Point detection relay number 3 to prove correspondence established at the end of operation. It is double coil relay. This relay operates when the point at site and point group is in correspondence on completion of point operation through point operation supply, that is 110 volt DC. Once energized at the end of point operation, stick through its second coil till such time WNR is latched. It operates during sequence of relay operation in point group when the point operation from normal to reverse is initiated to destroy the point detection through WKR1. The relay coil resistance comes under major groups. Relays coil resistance. Z1WR. First coil is equal to 1340 ohms. Second coil is equal to 1590 ohms. WLR. First coil is equal to 1340 ohms. Second coil is equal to 1590 ohms. Z2WR1 is equal to 1260 ohms. Z2WR2 is equal to 1260 ohms. TP1R is equal to 1840 ohms. TP1P2R is equal to 1260 ohms. Rest all relays resistance is same as in the case of minor point. Point chain group is provided with 8 relays. Point chain group is used only in route relay interlocking, that is, route setting type relay interlocking, and located on top of the rack above the major point groups. In case RRI, all the points in the required route are operated automatically. Chain group prevents the simultaneous operation of all the points of the set route in order to prevent the overloading of a 110 volt DC source, that is battery bank or charger. It staggers the points initiation, thereby staggering the points motor switching currents. One chain group is provided with 8 numbers of WWR neutral relays. WWR is normally drop relays. The circuit is designed in such a way that these relays will pick up one after the other and also drops one after the other. Normally, one chain group can cater 8 numbers of major point groups. Handle relay. Group 1, 1 point group. Crank handle CH slot release proving relay CHKLR. Electromechanical relays are provided at site. 1 group, 1 point group CHKLR normal proving relay CHKLCR. Group 2, 2 point group CHKLR normal proving relay etc. In cabin CHKLCR etc. Relay. Siemens motorized clockwork timer relay. This relay works on 110 volt AC. It has an adjustable time range of 1 to 5 minutes. Its resetting is automatic. When a synchronous motor drives and switches over contacts after the lapse of a preset time. If the energizing circuit is prematurely interrupted, the mechanism returns to its normal position before actuating the contacts. The relay has one changeover contact. The back contact is between terminals 3 and 4 and the front contact is between 3 and 5. The contact is rated for 100 mA at 60 volt DC. A set of 4 pinions and 4 gear wheels couple the motor shaft with the contact operating mechanism in this relay. The gear ratio is about 48:2:1 approximately. 2 or 3 helper relays of K50 type called AJTR1, AJTR2 and AJTR3 are used along with this relay for time control of circuits, so that the same time delay can be obtained for all operations. Flasher relay. Thermoflasher interrupts periodically with indication lamp circuits and brings about flashing operation of indication lamp. An oscillating mercury column enclosed in a U-shaped glass tube obtains the periodical flashing of about 60 impulses per minute. The movement of mercury column is caused by hydrogen gas in an interconnected glass chamber. In the lower portion of the gas chamber, heating element is placed. When the current is passed through the filament of heater, gas expands and exerts pressure on the mercury column in one limb. With depression of the column in one limb, the contact of the heating element Ga breaks, results gas gets contracted. The mercury column then returns to its original position by force of gravity. Now the heating circuit is closed again. This procedure gets repeated and swings the mercury column continuously till the external feeding circuit is opened. This opens and closes the contacts Ba, Ca, Da, Ea and Fa, alternatively, which can be used for the required indication controls. Normally up relays. Front contacts are normally available where relay is normally in pickup position. Example: TPRs, RECRs, WKR1, NWRK in panel interlocking, SHGLSR, GNCR, UNCR, WNCR, NNCR, ZR, WWYR, CHK, LCR, KLNPR, LXCPR, GXJR, WXJR, etc. Bottom relays by normal coil of interlocked relays. Relays UNS, ZUNR, OVZ, 2UNR. Normally down relays. Back contacts are normally available where relay is normally in drop position. The examples are all controlling relays, top relays of all interlocked relays. The examples are GR1, GR2, GR3, ZDUCR, URS, ZURR, OVZ2URR, etc. Symbols used in metal-to-metal relay interlocking system. Point contactor relay. Push button pressed contact. Panel key contact. Neutral relay. Interlocked relay reverse coil, that is, top relay. Interlocked relay normal coil, that is, bottom relay. Track relay. Track repeater relay. Time element relay. Block relay in automatic territory. Normal position of neutral relay is picked up. Normal position of neutral relay is dropped. Normal position of interlocked relay is picked up for normal coil. Normal position of interlocked relay is dropped for reverse coil. Make contact. Break contact. Neutral relay normally picked up. Make contact, that is, front contact. Neutral relay normally picked up. Break contact, that is, back contact. Neutral relay normally dropped. Make contact, that is, back contact. Neutral relay normally dropped. Break contact, that is, front contact. Interlocked relay normally picked up. Make contact, that is, front contact. Interlocked relay normally picked up. Break contact, that is, back contact. Interlocked relay normally dropped. Make contact, that is, back contact. Interlocked relay normally dropped. Break contact, that is, front contact. Relays connected in point circuit. Relays connected in root circuit. relays connected in signal circuit. The following are neutral relays. Point control relay, route control relay, signal control relay, point detection relay, route checking relay, lamp proving relay, point locking relay, route locking relay, signal locking relay. The following are interlocked relays. Reverse coil used for point control circuit. Normal coil used for point control circuit. Reverse coil used for locking the point circuit. Normal coil used for releasing the locked point circuit. Reverse coil used for route control circuit. Normal coil used for releasing the route control circuit. Reverse coil used for locking the route. Normal coil used for releasing the locking over route circuit. Reverse coil used for controlling signal control circuit. Normal coil used for controlling signal control circuit. Reverse coil used for locking the signal control circuit. Normal coil used for releasing the locking of signal control circuit. The following are the relay symbols used in metal-to-metal relay interlocking system. Point contactor, nomenclature, Nomenclature is a collection of simple and brief designations of apparatuses to describe their nature and location. The following are the meaning of letters used in general for relay nomenclature. A stands for approach, automatic. B stands for block, bell, battery positive. C stands for checking or proving. CO stands for calling on. CH stands for crank handle. D stands for clear or green signal. E stands for light, lamp, emergency, earth. F stands for flashers. G stands for signal control, gate signal. H stands for caution for yellow aspect. HH stands for attention for double yellow aspect. J stands for time for delayed action. K stands for indication or detecting. L stands for locking. M stands for marker, magnetic. MN stands for main. N stands for normal, button, battery negative. OV stands for overlap. P stands for repeating, permissible. R stands for reverse or danger, red, relay. S stands for stick. SH stands for shunt. T stands for track circuit. U stands for route. W stands for point. X stands for bell, buzzer or audible indicator. Y stands for slot or release. Z stands for zone, counter. Z1 stands for initiation. Z2 stands for overlap. Z3 stands for chain group. Z4 stands for isolation. The following are the relays nomenclature used in metal-to-metal relay interlocking. WNR, point button relay. WNCR, point buttons normal checking relay. WWNR, common points button relay for regular operation. EWNR, common points button relay for emergency operations. Z1WR, point group initiation relay with route setting. Z1WR1, point group initiation relay with individual point operation. Z1NWR, point normal operation initiation relay. Z1RWR, point reverse operation initiation relay. WLR, point locking relay. WRR, point operation circuit switching relay. WNR, point detection circuit switching relay. RWLR, point reverse operation control lock relay. NWLR, point normal operation control lock relay. WJR, point operation time limiting relay. WR, point contactor relay. WKR1, point detection relay 1 for point final detection relay to prove point correspondence continuously. WKR2, point detection relay 2 to prove point and point group out of correspondence and cross protection arrangement. WKR3, point detection relay 3 to prove point correspondence with point group at the end of point operation with 110 volts. NWKR, point normal detection relay. RWKR, point reverse detection relay. Z2WR1 and Z2WR2, panel indication controlling relays. WRLR, point group electrically locking relay. WNLR, point group electrically unlocking relay. YYNR, common slot release button relay. YRNR, common slot return acknowledge button relay. KLNR, key lock point control button relay. CHYNR, crank handle release button relay. CH or WW or EWNCR, CHYNRs, WWNR and EWNR, normal proving relay. KLRR, key lock point slot release relay. KLNR, key lock point slot withdrawal relay. KLCR, key lock point key in proving relay. LXNR, level crossing gate control button relay. LXRR, level crossing gate control release relay. LXNR, level crossing gate control withdrawal relay. LXPR, gate slot release proving relay. LXCPR, LC gate key in proving relay. CHYRR, crank handle slot release relay. CHYNR, crank handle slot withdrawal relay. CHKLR, crank handle key lock relay. CHKLCR, crank handle key lock in proving relay. CHKLCPR, repeater of CHKLR. UNR, root button relay. UNCR, root button checking relay. ZURR, direction setting relay for reverse. ZUNR, direction setting relay for normal. SHGRR, shunt signal selecting relay. SHGNR, main or calling on signal selecting relay. Z1UR, subroute initiating relay. MNGZR, main signal initiation relay. SHGZR, shunt signal initiation relay. ZDUCR, zonal route clearance checking relay or zonal route permissibility checking relay. OVZ2URR, overlap setting relay. OVZ2UNR, overlap normal relay. URS, route section setting relay. UNS, route section normal relay. UDKR, subroute clear indication relay. DUCR, route section clear checking relay. URLR, subroute locking relay. UNLR, subroute lock normal relay. GNR, signal button relay. GNCR, signal button checking relay. SHGNR, shunt signal button relay. GLSR, signal lock stick relay. SHGLSR, shunt signal lock stick relay. GR1, signal control relay 1. GR2, signal control relay 2. GPR1, repeater of GR1. GRLR, signal locking relay. GNLR, signal unlocking relay. GR3, signal control relay 3. GR4, signal control relay 4. COGGNR, calling on signal common button relay. COULR1, calling on signal control relay number 1. COULR2, calling on signal control relay number 2. RECR, red lamp checking relay. In automatic signaling section, RECR. HECR, yellow lamp checking relay. DECR, green lamp checking relay. In automatic signaling section, DECR. HHECR, double yellow lamp checking relay. UECR, route indicator lamps checking relay. COECR, calling on signal lamp checking relay. GXJR, signal lamp failure alarm relay. WXJR, point detection failure alarm relay. GXYNR, signal lamp failure alarm release button relay. WXYNR, point detection failure alarm release button relay. NNCR, buttons normal checking relay. EGGNR or ERNR, emergency signal common button relay to throw the signal to danger. EGNR, emergency signal button relay. EUUYNR, emergency full route release button relay. EUUYNCR, emergency full root release button proving relay. EUUYR, emergency full root release relay. EUYR, emergency subroot release relay. EUYNR, emergency subroot release button relay. ATR, approach track relay. AJTR1, approach lock release time control relay 1. AJTR2, approach lock release time control relay 2. AJTR3, approach lock release time control relay 3. AJTR, approach lock release timer relay. OYNR, overlap release button relay. OVAJTR2, overlap release time control relay 2. OVAJTR3, overlap release time control relay 3. OVAJTR, overlap release timer relay. EUUYZ, emergency full root release operation counter. EUYZ, emergency subroot release operation counter. OYZ, overlap release counter. CHYZ, crank handle release counter. EWZ, emergency points operation counter. Relay group indications. Various indications are provided on the relay groups used for various functions such as signal, route, and point. These indications give the functional status of the group. It helps the maintenance staff for easy identification of failures. Main signal aspect group. 3-aspect main signal group. 2 indications, red indication RKE and green indication DKE, are provided on the group. The table shows the signal conditions and the corresponding indications on the 3-aspect signal group. When the signal is showing on aspect, red steady indication glows on the 3-aspect signal group. When the signal is to show on aspect and on aspect lamp is fused, red flashing indication glows on the 3-aspect signal group. When the signal is showing yellow aspect, that is HG aspect, green steady indication glows on the 3-aspect signal group. When the signal is to show yellow aspect, that is HG aspect and HG aspect lamp is fused, green flashing indication glows and red steady indication glows on the 3-aspect signal group. When the signal is showing green aspect, that is DG aspect, green steady indication glows on the 3-aspect signal group. When the signal is to show green aspect, that is DG aspect, and DG aspect lamp is fused, green flashing indication glows on the 3-aspect signal group. When the signal is taken off and it is blank at sight, green flashing indication glows on the 3-aspect signal group. 2-aspect main signal group. 2 indications, red indication RKE and green indication DKE, are provided on the group. The table shows the signal condition and the corresponding indications on the 2-aspect signal group. When the signal is showing on aspect, red steady indication glows on the 2-aspect signal group. When the signal is supposed to show on aspect and the on aspect lamp is fused, red flashing indication glows on the 2-aspect signal group. When the signal is showing off aspect, green steady indication glows on the 2-aspect signal group. When the signal is supposed to show off aspect and off aspect lamp is fused, green flashing and red steady indication glows on the 2-aspect signal group. When the signal is taken off and it is blank at sight, green flashing indication glows on the 2-aspect signal group. signal group. 4 indications, that is 2 indications for each shunt signal, are provided on shunt signal group for 2 shunt signals. First 2 indications are for first shunt signal and remaining 2 indications are for second shunt signal. The table shows the signal condition and the corresponding indications on the shunt signal group. When the shunt signal is showing on aspect, red steady indication glows on the shunt signal group. When the shunt signal is supposed to show on aspect and on aspect lamp is fused, red flashing indication glows on the shunt signal group. When the signal is showing off aspect, yellow steady indication glows on the shunt signal group. When the shunt signal is supposed to show off aspect and off aspect lamp is fused, yellow flashing indication glows on the shunt signal group. Universal root group. It is meant for one subroot. 2 indications, red and yellow, are provided on the group. Normally, no indication lits on this group. The table shows the subroot conditions and the corresponding indications on the universal root group. When any one of the root section in the subroot is set, red steady indication glows on the universal root group. When subroot is locked, yellow steady indication glows on the universal root group. Minor point group. One red indication, RKE, is provided on minor point group. Normally, red indication is steady and the same indication will flash during operation of point and during the point failure. The table shows the point condition and the corresponding indications on the minor point group. When point is set, locked and detected properly, red steady indication glows on the minor point group. During point operation, or when the point is failed, red flashing indication glows on the minor point group. Major point group. There are 3 indications, 2 yellow indication, HKE, and 1 red indication, RKE, are provided on this group. First yellow indication is normally steady and same indication will flash during operation of point and during the point failure. The table shows the point conditions and the corresponding indications on the major point group. When point is set, locked and detected properly, first yellow steady indication glows on the major point group. During point operation or when the point is failed, first yellow indication starts flashing on major point group. When point is electrically locked through root or overlap or isolation, middle yellow steady indication glows on the major point group. Under root setting conditions, point group initiation fails and initiation stops with Z1WR and WLR picked up. Middle yellow indication starts flashing on the major point group. When point zone track circuits is occupied or failed, red steady indication glows on the major point group. No indication is provided on mini groups and on point chain group.